Hello everyone and welcome back to our channel. So in this video we are going to start off with a new topic, number patterns, and you'll find this video and the video to come on number patterns under the number patterns playlist on our YouTube channel. So let's start off by the introduction of number patterns. So in earlier grades you saw patterns in the form of pictures and numbers. In this chapter, we are going to learn more about the mathematics of patterns. Patterns are repetitive sequences and can be found in nature, shapes, events, sets of numbers, and almost everywhere you care to look. For example, seeds in a sunflower, snowflakes, geometric designs or guilds or tiles, or the number sequence 0, 4. So 0, 4, 8, 16, 12, 16. And if you can notice, we are moving in fours. So 0 plus 4 we get 4, 4 plus 4 we get 8, 8 plus 4 we get 12, 12 plus 4 we get 16. So let's try to spot any pattern in the following sequences. So we have 2, 4, 6, 8. And using the knowledge we have gained and using the fact that this is a very common rhyme and saying 2, 4, 6, 8, 10, 12, we all know we are counting in twos, so this is quite obvious. So it's 2 plus, so we take this 2 and we find out how did we get to 4. So we say 4 minus 2, so you subtract the previous number and you get 2, meaning we are adding 2 to 2. So we say 2 plus 2 we get 4, 4 plus 2 we get 6, 6 plus 2 we get 8, and 8 plus 2 we get 10, and so forth. So the difference here is we are moving in twos. So now let's go into describing sequences. A sequence is an ordered list of items. So an ordered list of items, usually numbers. In this case, because we are dealing with mathematics, we are going to use numbers. Each item which makes up a sequence is called a term. So pretend we have the sequence 2, 4, 6, so 6 looks like that, 6 and 8. That's our sequence, right? So let's label it. We're going to label it sequence. And we say that each item which makes up a sequence is called a term. So this is a term, this is a term, this is a term, this is a term. So how are we going to label it? Let's use another color and we just do that, and that's going to be called a term. So we move on. So meaning this is our first term, second term, third term, and fourth term. So this sequence goes on, meaning, so we put those 3 dots, that means this sequence continues forever, so it never stops. We get to 1,000,000, 1,000,002, 1,000,004, and so forth. So sequences can have interesting patterns. Here we examine the types of patterns and how they are formed. So let's have an example. Quickly. So we're going to have 1, 4, 7, 10, 13, and so forth. So how do we get the movement or what we added to the previous number? We look at our first and second term. So this is our first term and our second term. And we look at them in such a way that we ask ourselves, from the number 1, how did we get to 4? We say 4 minus 1, which is 3, right? So we take this, we minus the previous number, and you get that your answer is 3. And then you double check. So from 4 to 7, if we say 4 plus 3, do we get 7? Yes. If we say 7 plus 3, do we get 7? Yes. And so forth. So that's a 13. And So there is a difference of 3 between successive terms. So successive terms means the two terms that follow each other. So those are successive terms. So the pattern is continued by adding 3 to the previous term. So we add 3 to this term, we get 4. We add 3 to this term, we get 7. We add 3 to this, we get 10. We add 3 to 10, we get 13. And we add 3 to 13, we get 16, and so forth. So let's have a look at another sequence. So we are going to have 13, 8, 3, -2, -7, and so forth. So how do you get it? We take this, the second term, and we minus from that. So we're going to say 8 minus 13, and we get -5. So that's our difference. But let's double check, because sometimes so we can add -5 to 13 and we get 8. But when we add -5, we don't get 3. So let's double check, and we say 8. No, we want to get this term here. So we say 3 minus 8, we get what? -5. Meaning there's a difference of -5 here again. So you'd write it as follows: 13, 8, 3, -2, -7, and so forth. So the difference here is -5. The difference here is -5. Let's double check the difference between -2 minus 3. So -2 minus 3 is -5. So that's correct. And -7 minus 2 minus 7 minus 2 is -5. And so that's our difference. The difference is -5 between successive terms. The pattern is continued by adding -5 to the previous term, or by just subtracting 5. So that's it. Let's have a look at another question. So let's make it a bit complex. 2, 4, 8, 16. So what do you notice about this pattern? I can say that so we can say 4 minus 2, we get what? 2. Then I say 8 minus, so let's write it like that: 2, 2 to 4, 8, 16. The difference here is 2. The difference here is 4. The difference here is 8. Meaning so there is not really a constant difference. If you can see, we don't have a constant difference. The difference keeps changing. We have 2, 4, 8, meaning we're going to go to 16 next. And so you'd have to analyze this and say, so what are we doing to this term to get the next term? We are timesing this by 2. So if you say 2 times 2, we get 4. If you times 4 by 2, you get 8. If you times 8 by 2, you get 16, and so forth. So that's our pattern. The sequence has a factor of 2 between successive terms. The term is continued by multiplying the previous term by 2. So we are multiplying the previous term by 2, and so forth. So there are a lot of sequences that go like that. It's just a matter of practice to get the hang of it and get the idea of how to actually determine the sequence. So to describe terms in a number pattern, we use the following notation. The first term of a sequence is T1. So let's take 2, 7, 9, 8, which does not make sense, but this is for explanation purposes. So this will be term 1, this will be term 2, because we just said the individual items that make up the sequence, this is the sequence, are called terms. So we're going to call them term 1, term 2, and term 3. Term 4 actually. So yes, the first term of a sequence is T1, the fourth term of a sequence is T4, the 10th term of a sequence is T10. So you just replace the n, so it's basically n, and you just replace the n with the number of the term. The general term is often expressed as the nth term and is written as Tn. And so that's what we have there. So that's the general term. So if you say T21, we mean term 21, and that's the general term. We mean term 21, but if we say Tn and we give the explanation maybe 2n, meaning we times every number by 2 to get the next term, and that's the general term. A sequence does not have to follow a pattern, but when it does, we can write down the general formula to calculate any term. For example, consider the following linear sequence: 1, 3, 5, 7, and 9. So the nth term is given by the general formula Tn is equals to 2n minus 1. Right. You can check this by substituting values into the formula. So you can say, okay, since you say that, let's check for T1, what do we get? So we say 2 times n is 1 because we're looking at term 1 minus 1, what do we get? So 2 times 1 is 2 minus 1 is 1. Let's have a look at T2. So 2 times 2, which is 4 minus 1 is 3. Let's have a look at 1, 2, 3, 4, 5. Let's have a look at T5. So we're going to have 2 times 5, which is 10 minus 1, which is 9. And that confirms that. So the general term is a general formula. So it's a general formula that tells us, or that allows us to see what a certain term is. So if they ask us, so now we just said our general formula is 2n minus n, right? And if they ask us to calculate T100, it's very tedious to write 1, 3, 5, 7, 9, and you keep going 11 up until 100. So you can just say T100 is equals to 2 times 100 minus 1, and that's 2 times 100 is 200 minus 1 is 199. And so that's how you get your T1 million. You know, you can never really get to 1 million unless you are willing to sacrifice days and weeks to get that. So there are easier ways to do math and to save time and to be efficient. That's why we have general formula. It makes life easier. So once you have the first few terms, then you can use those first few terms to get a general formula that will help you to get even the largest of numbers. If we find the relationship between the position of a term and its value, we can find the general formula which matches the pattern and find any term in the sequence. So it's just what I've explained. Now let's consider the sequence 6, 1, negative 4, and negative 9. So let's write it down. 6, 1, negative 4, negative 9. We can see that each term is decreased by 5 because we say 1 minus 6 is negative 5, meaning we subtract 5. So if we take 1 and subtract 5, we get negative 4. If we subtract negative 5 from negative 4, we get negative 9. So that's how we get the sequence. So we have a constant difference of negative 5. But how would we determine the general formula of the nth term? You can see that. So let's try using a table to do that. So we have the term number. I'm going to say term number, and if you don't know, hashtag represents number, then term, let me just use T, and then formula for F. And let's have this table that will help us determine the value. So we have T1, T2, T3, T4, and T1 we say it is 6, T2 we say it is 1, T3 we say it is negative 4, T4 we say it is negative 9. So if we look at this, we can see that the formula is 6 minus 0, right, times 5. Then we have 6 minus 1 times 5. Then we have 6 minus 2, which is 4, times 5, and so forth. You can see that the difference between the successive terms is always the coefficient of n in the formula. Therefore, the sequences with a common difference sequences with a common difference are called linear sequences. So sequences with a common difference are called linear, as in straight sequences. And that's it. So let's define common difference. So what do we mean by a common difference? We mean the common difference is the difference between any term and the term before it. The common difference is denoted D. So the common difference is denoted D. So the common difference is the difference between any term and the term before it. So that's why we took so if we had 1 and 4 and 8, we took 4, this 4, and we subtracted the term before it, which is 1, to get 3. So it's the difference between any term and the term before it. So now, for example, to calculate the common difference, we find the difference between any term and the previous term. Let us find the common difference in the first two terms using the following sequence. So 10, 7, so let's write it right there. So 10, 7, 4, and 1. And if we were to find the common difference, it would be 7 minus 10, which is negative 3. And 4 minus 7 is also negative 3. 1 minus 4 is negative 3. So you take the number in front. So let me use another color. You take the number in front and you say that number minus the previous number. So 1 minus 4, you get negative 3. Then you say 4 minus 7, you get negative 3. Then you say 7 minus 10. So that's what common difference is. The definition is the common difference is the difference between any term and the term before it. So our D in this case would be negative 3 because D denotes common difference. We can see that D is constant because every time you subtract from the term, so you take the term and you subtract the previous term, you always get negative 3. That's why it's constant. So it's constant difference. And in general, we define constant difference by saying D is equals to Tn minus Tn minus 1. Meaning, if Tn is 2, then we're looking at T2, right? And Tn minus 1 is, so it's 2 minus 1, 2 minus 1, which is 1. So it's basically D is equals to T2 minus T1. And if you have a sequence 1, 4, 3, whatsoever, and we say this is our first term, this is our second term, this is our third term. So our second term here will be 4, and our first term would be 1. That's why we say 4 minus 1 is 3. So, and you can never do it the other way around. You can never say T1 minus T2. It's always the number that's in front minus the previous number. So you can never say So notice the formula can never be Tn minus 1 minus tn. You can't do that. It has to be any term and the term before it. So that is it for this video. Thank you so much guys for watching. See you in our next video as we tackle some more concepts when it comes to number patterns. Bye.